This is a very sophisticated robot that does very unique type of measurement that gives us a very clear picture of the entire frequency response, something that would typically require anechoic chambers, a very big anechoic chamber. We can do it all in here at a much higher precision on much greater range of points in space, so we can get literally a 360 degrees look of what the speaker is doing. And I'll show you, Yair, our CTO, can run it real quickly so you guys can see that. You might want to take a picture of Yair. Are you there?
No, close.
Yes, I'm here.
All right, so I have Jay and his wife here, and oops, watch that. Yeah, let's stand here. And just give a brief explanation of what's happening here.
Okay, so...
Oh, it's running, okay.
Martin will show them a little bit and then I'll speak.
Okay.
So it adjusts for each point and takes a measurement.
Let me hear you here. Go ahead.
It adjusts for each point and takes a measurement.
And we typically do 2,000 to 3,000 points around.
Wow.
And it does that 360 degrees.
Wow, that's impressive.
So one of these measurements takes 12 to 16 hours.
12 to 16 hours they can take all these measurements? Wow. That is
Okay,
incredible.
here we can stop that.
And so we then do it on each individual driver, and then we'll do it on the complete speaker with the crossover. So you're looking at
About a week.
So about a week of
A week.
About a week of full-time measurement.
Yeah.
For one speaker.
Wow.
Great,
So,
great way.
this is 2 weeks. So every speaker
All
will
right,
go
so
through this
take a look at the screen
before it
here.
gets packed up. So, wow.
And the
Here, make it
R&D.
short. You don't need to go into
So, but
too much
but then what is the purpose of what you did over there inside? Is it the same with the MC?
That's strictly QC.
Okay.
For outdoor. This is
This is-
strictly R&D.
It's R&D. Got it. And the other one
This
was...
is how we designed the crossover, basically.
Oh.
And designed drivers. All right, you ready? Yeah.
Hi.
Yeah, we're hearing you.
Okay, so the idea behind the robot, behind the what is called the near field scanner, is to give the possibility to make measurements which was only be possible in an anechoic chamber inside a standard warehouse, factory, any room, basically. The room needs to be not very small, of course, but it needs to be, it can be any room. And the idea is to generate through calculation and very interesting method to create a frequency response that correlates only to the speaker and not taking into account the room. In order to do that, the robot is creating a pattern of a cylinder that moves and circulates around the speaker, and it does it in two radiuses. So it does two cylinders, and using very sophisticated calculation, it's able to correlate what's coming from the speaker and what's coming only from the room, and then what we are able to do is to get a frequency response. 1 second, let me show it to you clearly, like this one, which is going down to very low frequencies at a very high accuracy. And this is very hard to do without doing it in an anechoic chamber. This, on top, another thing is that it is able to collect multiple measurements of all the radiation, meaning all angles in the 3D space that the speaker is targeting to. enables us to see all the behavior of the speaker, and enables us to create a much better understanding how the speaker will actually work in a room. And the issue about it, first of all, previously we had to do it in an anechoic chamber. The other thing is we had to do semi-manually all those points. And the equivalent of a measurement that's done in 12 hours using this robot is about at least 2 to 3 weeks of a very talented and trained person in an anechoic chamber, which means that actually to make a lot of those measurements in order to perfect the speakers would have taken months and months and months, and this is much reduced due to the NFS. So we get a lot of precision, we get a lot of information, we get a lot of detailed information, and we can improve the speaker as much as we can.
Yair, can you? By the way, this is just a base driver. So
wow.
Can you show a full range measurement, please? This is A5 measurement, the whole thing.
Wow.
And this is like including the on-axis, the listening window, the reflections, the sound power, which means actually the whole sound radiated into the room, and things that calculated the relationships between the on-axis to the power, the on-axis to the early response, and we can get a calculated estimate of what the sound will be in a room.
Wow.
So you can see,
this is following our target.
Remember we talked about how smooth things are on and off axis.
Yes.
They should cover each other.
Right.
So if you look at, let me move this. If you look at this, you see how the curves are following each other.
Yes. Magico R&D at work, folks, so you understand what they do here to test the speakers and obviously assess the frequency response in the room, and everything else that goes with this process.
Alon, I think that I can operate the animation and you can explain.
Okay.
So
this is ours.
So this is actually an A5, sample of an A5, and that's another speaker that is built from MDF. So you could see what happened to the panel when it's an FDF panel, and what happened when it's a properly built aluminum enclosure. You hear those things. This is basically allow us to see the frequency response of the enclosure. Anything that you see above 20 here is audible. All this area here, you actually hear it. It becomes part of your presentation. This is the coloration
of the cabinet
we keep talking about.
Yeah.
Yes. So you might like it on certain things, but it's there on everything.
Got it.
And this is the difference. Ignore the high frequencies. That's more noise than anything else. But anything below 1,000 or 2,000 is quite critical. And you could see the difference between a properly built aluminum enclosure, and this is a very well-known loudspeakers, almost as expensive as the A5, but not quite. It's the same cost as the A3. This is where the money goes.
Got it.
You could see why.
Essentially eliminating the cabinet as much as possible
Yes,
from
because
influence.
it's part of your output.
Right.
And it's not supposed to be there. It's not
Right.
the recording.
Yeah.
It shouldn't be there.
Right.
Yeah.
That's incredible. So this machine here, essentially, you play a test
Yes.
tone, and this laser hits the cabinet, and
Yeah.
it sends back that information.
Right.
So that,
And we can see when we do R&D, we could see parts that needs to be addressed. So we could either damp it more or we can put more bracing. Aluminum allows us to do that. With MDF, it doesn't matter how thick you're going to make it.
it's still going
It's
to be.
still going to move because it's not stiff enough.
Got it. Understood.
So, of course, it doesn't. This is violent. This just exaggerate the movement.
Right.
But you could see that this is the type of stuff that you end up hearing.
And once again, this is through every single speaker,
Every single
regardless
speaker.
of price.
Absolutely.
Every single one of them goes through this testing.
I mean, design-wise, once it's designed, you
Yeah.
need to do that. This is
Got
not
it.
this is not a QC part. This is a design part.
And you've been doing this since the beginning of time, or this is something that
No,
you?
this is something we. I mean, this is a serious investment here on our part. So
sold across.
we-
Yeah.
Yeah, this is we're just designing cross.
Okay.
But it's been 2 years since we
2 years.
acquired these tools. Yeah.